Okay, I accidentally turned on the live caption. Okay. Right, let's look at this example. So we have a U pipe shape, and the fluid is water. So water flow through 180-degree pipe bend, as you can see on your screen here. And this one is question number 25 in your tutorial question. So the cross-section area is given in cm square through the bend, and magnitude of the flow velocity everywhere axial is 15 meter per second. Axial means that your flow velocity at the center of the pipe, right, is 50 meter per second. The pressure at the entrance and exit band is given. So input and output pressure is given. In this case, it is kilopascal. Right? So we need to calculate the horizontal component of the anchoring force. Okay, the anchoring force required to hold the band in place. So in this case, you pump water from section 1, going in 50 meter per second. Then it will go along the pipe, come out at section 2, and the axis is given. In this case, you are dealing with 3-dimensional question. So you have an X in this direction, Y, and Z direction. Just help you a little bit, there's a velocity vector diagram on the right hand corner. Okay, just to remind you, X is U. If you look at Y, you use V for the velocity, Z you use W. So we need to find the anchoring force again. So anchoring force means that what makes the force that make the shape of 180-degree in place. So if the material is not strong enough, if you pump water from section 1, section 2, you're going to flip to the right. You're going to change shape and cannot withstand this shape 180-degree. Okay, so I'll just move forward. So the first step is to draw the control volume diagram. So like what you see on the screen here. So in the test or final exam, it's going to take you maybe 5 to 10 minutes just to draft the diagram. Okay, so again, I repeat the SOP, the steps. First, control volume. You trace the shape that you see in the solid line here. You trace and then draw the control volume. After that, label your input, output, in, out. Step number 2. 3, draw the axis. If you can, draw the axis. Okay. Then number 4, you put in the forces, or you can put in the velocity if you want. So number 4, you put in the velocity, V. Okay. Now the velocity, why this case is V? It because your Y direction is in this direction. So that's why you are using V and not U and not W. Okay, because the flow is referring to this axis here. And the flow is going in along y-axis. So you are using V rather than U or W. Okay, so after you input the velocity, same with this one. So this one also your velocity come out along y-axis, so you are still having a U direction. So after you have the velocity, you can input the force. The last one is the force, or the force, pressure, and the reaction force. So on the left-hand side, you have the inlet, and again, you convert pressure into forces. Okay, so you have to know how to convert pressure into force or convert from force to pressure. So in this case, you take pressure times area of this section. Okay, and you have to know already, you're having a circular shape. Diameter is given in the question. So you manage to find the area of the circle. After that, you continue with the anchoring force or the force component also. So in this case, you have 3 components in here or at this section at the middle of the pipe here. So this one maybe you label as point A. So point A, you're having the X direction, Y direction, and Z direction. So all these direction you need to refer to the reference axis and not your own axis. So this is important. So you have your AX, AY, and AZ. And in this case, you need to consider the gravitational force, which is your G. Okay, which is your weight at this corner. So you're having a weight of the water and also the vessel if it's asked. So normally we will only look at the fluid, and previous example you're having a nozzle mass also. So in this case, we need to consider the fluid and also the vessel or the pipe, unless the question asks you to ignore the pipe. Okay. So these are all the steps when you set up the free body diagram. Okay, once you have the free body diagram, you have the forces, you have the control volume, you have the pressure convert to force, the velocity in and out, then you are ready to solve by using the equation, the linear momentum equation. Okay, so all these are notes you can see. So you will use the linear momentum. Again, linear momentum, don't confuse with the continuity equation. We are looking at linear momentum. So we're still looking at mv divided by t. This one is mv divided by t. This one gives you forces. Okay. Then it because how we know it's steady, it is because you look at the velocity here, or you go to the question, this statement, magnitude of flow velocity everywhere in a band is actual and 15 meter per second. It means in, out is the same. There is no loss of energy. So it also means that you have a steady flow. Okay. Then you can go to the equation, draw the blue arrow, write 0, write steady. Again, in exam, if you only draw an arrow without telling me what do you mean, I'll put a question mark there and you will not score any marks. Okay, you need to explain why you draw an arrow or why you cancel. Okay. So you draw arrow, write 0 because you have a steady flow. Then you only need to focus on this component. You calculate this component. This component you derive from the free body diagram. Okay, all the force. So I will slowly guide you through. So since you have all the 3 axes, so you need to calculate the x-axis, y-axis, and z-axis. So when we look at this component, we start with x direction first. This is x direction. So when you look at x direction, the u will become x. When you look at x direction, you are using u. Rho Vn same, but the force direction is all the force in x direction at point A. Okay, then you derive, this one is the y direction, this one is the y. Okay, this section is y. So when you look at y, your v changed to v. This one same. Then you look at all the forces in y direction by referring to this diagram. So if you look at the direction, you have this one, you have this one, you have this one, okay, in y direction. X, already know lah, x you only have one, fx here. Okay, next, you look at the fx here, there's an explanation there. The flow is in y direction, and therefore the u is 0 for both cross section. The flow is in y direction, so there's no u direction. Okay, there's no u direction inside the pipe. Although here there are some turning force, turning velocity in x direction, but it's very small compared to what you have in and out here. Okay, so there's no x direction flow. So that's why for this section you need to write, if there's no x direction, you need to write u equal to 0 because what? Okay, in this case, because the flow is in y direction, that's why your u component, this one, u equals 0. So when this one 0, this one also 0. Okay, so your fx equals 0. You get, actually this one is a free marks if you understand the question. Okay, fx equals to 0. Then you move to the next one on the y hand side. So I clean up the board. I continue looking at y component. So this is y component or y direction. So you have your v here, and you have all the force if you refer to diagram. So you have y direction, y direction, y direction. Okay, so be careful when you analyze. So we have done the forces already. I explained how you get the forces. Now we focus on here. So this component, you only need to concern where is your in, where is your out. So if you only have one inlet, then means that your answer, you have one negative sign there inside here. You have one output, means you have one positive value for control surfaces component. Okay. All right. So the rest is just substitution. So that's why you are seeing this component is negative. It is because if you look at point 1 or input always negative. This one is positive sign. This is positive. It is because it is output. Okay, so I explained about the positive negative already. Next, just now, previous example, I explained about how this combination rho AV or rho VA give you m dot. Okay, so same input here, you have one m dot here, you have another m dot here. This is 2, this is 1. So in equation, you have m1 dot, m2 dot. Okay. After you have done the m dot, then you just substitute what happened to your input, what happened to your output. So there's a sign there, also be careful. So this sign referring to axis, reference axis. This whole equation refers to y direction. So all direction to the right is positive. That's why your V1, what is this one, is positive. And if you look at 2, it is because going this direction, it is negative. Because your y direction is positive to the right. Okay? The rest is mathematics steps. No further explanation needed. You rearrange the equation to find what is your AY, FAY, this one, by substituting all the known value. Okay. So just to recap how to calculate the m dot. M dot is rho AV. So you have the rho, you have the area, you have the velocity, you're able to find the m dot. Okay. So m dot, I'm not going to give you the answer, but you should know the way to find it. Okay. By substituting all the value. Put the answer in kilogram over second for m dot. Substitute all the value in, you manage to find your FAY in Newton. Okay. You need to find out lah. Okay. Then, okay, I already done the first solution. Okay, first solution. There are two ways. So the second way is that you can include the atmospheric pressure by this diagram. So you can see what is happening here is that the forces diagram that you see on the lower right corner of your screen, you'll be seeing that atmospheric pressure was added inside the free body diagram. And you're having a Ry here. Okay. So there are two methods, but still give you the same answer at the end. Okay, let me look at the time. Okay, I go one, maybe at this one I save for next lecture. Okay, we stop at here. Let me stop the recording.